Okay, let's look at example 2.7. This is an example, as we talked about, using the unit vector in a three-dimensional case, defining the unit vector and using that to find the forces, or to define the rest of the vector. So what do we have here? We have this tower. It has a guy wire from A to B, and the tension in the guy wire is 2,500 newtons. Well, what direction is that force going, right? Here at A, there's being a force applied, and that force, the beauty of wires, is you know the direction that they're applying it. It's only going that direction. That's 2,500 newtons, right? That's because a wire can't do anything else. So what we are supposed to determine is the components of the force, the x, y, and z components of the force acting at A. Okay, and we're also supposed to determine the angles theta x, theta y, theta z, defining the direction of the force. Okay, so how do we do that? Well, we need to, in the example we talked about, or in the slides, it talked about creating a vector D. So let's create this vector D. Now, honestly, I don't find D overly helpful as a name. So what I want to call it is I'm going to call that from A to B. And what is the vector from A to B? Well, it has an x, y, and z component, right? You have a y component, an x component, and a z component. So the x component does what? It's minus 40 in the I direction, right? It's going to go plus 80 in the j direction, and it's going to go plus 30 in the k direction. Because from A to B, it has to travel the 40 in this direction, has to travel the 80 in this direction, and has to travel the 30 in that direction to get to to get to this point right there. Okay, so that is D. Now, in and of itself, that's not overly helpful. It's really just an intermediate step. Why do I say that? Well, because D is really, we don't care about D. We want lambda. We want to know the direction of that vector. So how do you find lambda? Well, lambda is simply D divided by the magnitude of D, right? So it is minus 40I plus 80j plus 30k divided by the magnitude. Well, what is the magnitude? Well, it is the square root of 40 squared plus 80 squared plus 30 squared. So it turns out that lambda is minus 0.424 in the I direction, plus 0.848 in the j direction, plus 0.318 in the k direction. Okay, so that is our unit vector. So what does that tell us? Well, we talked about that the force vector is equal to the magnitude of the force vector times the lambda in the direction of the force vector. So what is the magnitude of this? Well, it's 2,500 newtons. We already know that. We've been given that, right? You can put a gauge in there. You can put a spring a spring scale in there. You can measure that, and now you know the direction. So the force vector, the force from A to B, is going to be 2,500 times that vector, which I don't feel like rewriting. So that works out to be minus 1060 in the I direction, plus 2120 in the j direction, plus 795 in the k direction. And that is the type of answer that I would expect right now, right there. Now, having said that, that's not exactly what they asked for. They asked for fx, fy, and fz. So let's be clear here. Fx is equal to minus 1060, fy is equal to 2120, and fz is equal to 795. But here in vector form, this is what I would generally expect answers in that form right there. So that gives us our fx, fy, fz. Now we're not done. Well, we're done with part A, right? Now what is part B? Part B is asking us to determine the angles theta x, theta y, and theta z. Well, how do we do that? We go back to this understanding of what is fx, or what is theta x, theta y, theta z. Well, what is fx? Fx, do you remember this, is f cosine of theta x. Well, we know fx, right? It's right there. That's supposed to be a 6. We know f. What is f? It's right here. It's 2,500. right? So we can just solve for theta x. So therefore, theta x is equal to cosine inverse of fx over f. So in this case, it works out to be, when you put minus 1060 over 2500, it's 115 degrees. Fy is, again, f cosine theta y. So theta y is cosine inverse of fy over f, which ends up being about 32 degrees. And fz, based on f cosine theta z, so theta z is cosine inverse of fz over f, which works out to be around 71.5 degrees. And those are your answers. That theta, again, I'll rewrite this as theta x is theta y is theta z. Now, for some reason, since we usually write it like this, you want to think, a lot of times the tendency is to think that you have to have theta z in order to figure out fz. But we already figured out fz. We did it right here, right? We figured it out like this using the lambda, and we figure out f because that's the known. So then we can figure out the theta x, theta y, and theta z right there. And those are our final answers.